For advanced work packaging programs to be effective, the right information is needed at the right time, in the right format, and at the optimum frequency. This working group focused on identifying the minimum data required through all stages of a project lifecycle to support effective AWP implementation. The team also developed an implementation guideline to assist organizations in adoption of the minimum AWP data requirements. These requirements can now be defined in contracts to facilitate a successful AWP program. Here to present their findings, please welcome Tom Morris, Ted Weitzman, Stephen Jones, and Adam Messersmith.
Okay, good morning, everyone. My name is Tom Morris. I think most of you just met me in the intro. Just very briefly, if you missed the kickoff session, I lead a team at ExxonMobil that we call the AWP Center of Excellence. So we're a team charged with promoting and supporting advanced work packaging within ExxonMobil. And today I'm here before you as a member of the AWP Joint Working Group, the team that has worked on these data requirements. So next slide, please. Yeah, so digitally enabled AWP. This team's been working very hard for right at a year now to come to this day and be able to share with you. So we're all really excited to be here. So I'm going to kick off the group. I'll take you through the agenda, give you a little bit of context. So the first thing I'd like to do is we'll connect on AWP itself just briefly. Why are we bothering in the first place, and how does digital play into that? The next thing, I'll hand it off to one of my teammates who will be looking at an overall system architecture, showing you what that looks like. And then we will have a presentation on the data requirements themselves, as well as how the team functioned and a little bit of how we got to our final product. And then we look very much forward to taking your questions at the end of this. All right, so digitally enabled AWP and CII data requirements. On the next slide here, I'd like to start with introducing the team itself. So those who are able to attend the kickoff, you heard from Jay Moser directly a little bit about how this team came together. And it was quite the unconventional team. So I've been a part now of 2 normal research teams, and then this was my first exercise in something like this. And it was different, and I think it was special in a lot of ways. And a few things I would point out. One, we were a team of volunteers. So as Jay was describing, we came together, saw a common problem, and we're willing to roll up our sleeves and get to work, going data table by data field to hash this stuff out. So really a debt of gratitude to everyone you see on this slide. To put a little more context around the team structure, there was a joint working group, which became a pretty large body. There was a lot of energy and interest in this work, but what we quickly found was at the level of detail we were working at, we needed to be able to bring a smaller team together to be able to work the details that we could then report back to the broader joint working group. And that's what we ended up informally calling the core working team. And those are the names that you see here on the page. The core working team, I'm not going to read every name in every company, but one thing I would highlight that I'm proud of is the diversity of function represented on this team. So you will see owners, you will see EPCs, and you will see software and technology companies. And having that perspective of each of these stakeholders all sitting at the table and in the minutia of the work that we were doing, I think was our greatest strength. And then the cherry on top is, if you look, toward the end of our work, we did get some funding, and we were able to bring in some academic partners from Georgia Tech who were able to work with us to really get our work in a final publishable form and get us over the finish line. All right, so I'd like to take a step back and reconnect on advanced work packaging itself for a moment. So why are we bothering with all of this? And I'd actually like to talk through this page here in a little bit of a reverse order and start with safety. So those of you maybe a little more connected to the AWP journey may be familiar with RT319. So our T319 was a previous research team that was charged with validating AWP and trying to demonstrate that it brought the value that we all intuitively thought that it could. One of the case studies that stuck out in my head after all this time, and I haven't read it in a few years now, was a tale of two projects. Really this perfect case study of you had a project that was implementing advanced work packaging, and you had a project that was not, but the scopes of the project, they were the same. It was the same owner, it was the same EPC, it was executed in the same region. Two sister projects, just at different sites. So you really just couldn't get a better apples to apples comparison. The project that implemented AWP, fantastic safety performance, 0 recordable injuries. The project that did not, unfortunately, did end up, we had people get hurt, we as an industry. I think it was 12 recordables on that job. So if you attended for day one yesterday, there's a line I love to take from my colleague at Exxon, Jamie Gerbrecht. If you take a step back and look at no recordables, 12 people getting hurt, that alone, I think, is plenty enough reason to go after this advanced work packaging journey. But even better than that, there's more on the table, and that's where we can start marching up the slide. So 25% more time on tools, 10% reduction in cost. I'll add to that accelerated schedules and schedule certainty. There's so much benefit that this type of planning methodology can bring to our projects, and we really want to go unlock that potential. So that's why advanced work packaging. Let's take a moment and talk about how digital plugs into that. So next slide, please. So advanced work packaging in of itself it's really a planning methodology. I like to say it's two things. It's getting engineering and procurement in line with a construction and startup sequence. So bringing everyone to the table and coming up with one plan. And then it's work phase planning. It's proactively managing those constraints at the work phase so our workers can be safe and efficient. Now, to achieve that, hypothetically, I can do that with paper and pencil. Now, we work in the 21st century. I would hope that on project of really any scale, we wouldn't be looking to just paper and pencil, but fundamentally, this is a work planning process. Where data and digital enablement comes into this is there's a whole host of slick tools out there, pieces of software, a great deal of technology that we can bring to bear that can really drive a step change in our project performance. I'll steal another line from a teammate on this team, Ted Weitzman, who says digital enablement supercharges an AWP implementation. The challenge with all that is the data is fundamental. If I don't have my data right, if different parties and different stakeholders across the enterprise of a project can't share data, can't share it in some sort of a common delineation where system A can talk to system B and it doesn't really matter what space they live in, then we're just stuck at square one. And I think the reality industry right now is we are too often either stuck in that mode or having to reinvent the wheel on every project, trying to figure out what are those data requirements and those data contracts, and how do we tie all of this together? And that's the problem this team came to try to solve. So I'd like to hand it off next to Steve. Every team member who's presenting today will provide their own introduction, and Steve's going to take over and share what such an architecture can look like.
Hey, Tom, thanks. Hi, everyone. Good morning. My name is Steve Jones. First of all, I'd like to say how grateful I am to have had the opportunity to work with such a talented and dedicated group of people. I really learned a lot and look forward to continuing to work with this team in the future. A little bit about my background. So I have background with Shell in engineering data management to support the various phases of capital projects. And I've also worked over the past couple of years to support the digitalization of advanced work packaging on projects. And I think some of this experience has been key in allowing me to make contributions to this effort. Today, I'm going to talk about the digital enablement of advanced work packaging, the goals of this digitalization, and the benefits. In the first slide that we see here, we see an example of an AWP framework and the types of applications and integrations that are required to digitally enable AWP. So how do digital threads and data requirements relate to this model? Every place in the example where you see a bidirectional blue line, digital threads are required to define the transfer of information needed as input or output by any one of the applications or processes shown on the slide. Okay, so what's the difference between a digital thread and a data requirement? Well, the digital thread is the container in which the data requirement resides. In addition to the individual data requirements or subthread definitions, the digital thread provides an overview of the business function. This overview contains information such as timing and frequency of when data is required, sources and destinations of the data, work processes associated with the digital thread, and a definition of team roles related to the thread. These digital thread definitions, as just described, were developed by ConstructX, and the existing library of digital threads and data requirements were donated to CII by ConstructX as the starting point for our work. This team's focus was on defining the data requirements for the subthreads embedded within the digital threads and creating an implementation guide to support these definitions. At the center of this slide, you see the data integration layer. This is the heart of the AWP framework technology stack. This is where the electronic management of data takes place and where data exchange is facilitated between the landscape of applications that support AWP on any given project. This is where all of the processes or microservices for the consumption, validation, and transformation of data threads are implemented programmatically or through system configuration. This layer is what allows projects to really maximize the value of individual systems that are integrated through data threads. It also serves as a single source of truth from where data can be aligned across various systems and where historical data can be tracked to provide visibility and oversight to projects. Last but not least, the data integration layer provides a platform from which handover to asset can be launched. The main point to be made here is that the data requirements definition provides the level of detail that is absolutely necessary for the enablement of digital AWP through a technology stack, such as the example seen here. We need the data requirements in order to enable this technology stack. Nothing's possible without upfront requirements. Next slide, please. So what do we want to achieve through the digital enablement of advanced work packaging? The point of digitally enabling advanced work packaging is to employ automation to greatly reduce time spent manually handling data. Excuse me. Repetitive processes such as data quality and inconsistency checks can be programmed or configured and scheduled to run on data as it arrives. Systems can also be configured to automatically generate notifications to request a correction and resubmittal of data from external sources when data quality issues are discovered. We really want to stop the progression of invalid data as early as possible. For example, if we allow the early design inconsistencies to propagate throughout execution, issues related to those inconsistencies begin to multiply and eventually lead to possible delays or rework during the construction phase of the project. Digitally enabling AWP also allows us to fully automate the aggregation and transformation of data into the required output for consumption by other systems. To re-emphasize, this automation is only possible if the data requirements have been defined and are made available as the foundation for the implementation of a digitally enabled AWP framework. Having industry alignment on the data requirements definition will allow stakeholders to spend less time focusing on defining requirements and spend more time on the digital enablement of the requirements to meet business goals. Next slide, please. What are the business goals that we want to achieve? The purpose of defining the digital thread data requirements and digitally enabling AWP through the technology stack is to satisfy the business goals as they relate to advanced work packaging. One of the main objectives is to increase the overall efficiency of work-phase planning, which can be done through reducing manual data entry, data validation, and data cleanup by implementing repetitive processes through automation. Efficiency is increased by eliminating issues such as scheduled delays and rework, which are introduced when data inconsistencies are not addressed early and allowed to propagate through design and into execution phases of the project. Digital enablement of AWP also allows us to resolve typical challenges related to incorporating materials management into work phase planning by providing materials availability data to the workplace planning system through digital threads. This leads to the overall target goal, which is the issue of 100% constraint-free IWPs. Having a system that allows workplace planners to see materials availability is a great example of how this can be achieved. This allows planners to issue IWPs knowing that the materials needed to execute are available on-site and easily located. To recap, we have talked about the digital enablement of the AWP framework through a technology stack, how digital threads and data requirements are related to this framework, the differences between a digital thread and a data requirement, how the data integration layer is the heart of this framework and how its implementation is not possible without data requirements. We have talked about what we want to achieve through the digitalization of advanced work packaging, how we can reduce time spent manually handling data by automating repetitive processes, how we can identify data quality issues early and prevent those issues from propagating into later phases of the project. And most importantly, we have talked about the business goals, with the target being the issue of 100% constraint-free IWPs. Well, thank you for your time today, guys. I really look forward to the opportunities and benefits that arise as we come one step closer to industry alignment on an advanced work packaging data requirements definition. Stay safe, and over to you, Ted.
Thank you for that, Steve. I am Ted Weitzman. I am a Director of Delivery Excellence for ConstructX. I've been with ConstructX for almost 2 years now. Previous to ConstructX, I was with Southern Company and working in what was called their Engineering Construction Services Group for almost 18 years. Cut my teeth in electrical retrofits and ended my career at Southern Company, really specializing in asset lifecycle information management. As it relates directly to CII, I was a FIATech board member as FIATech went through the transition process of being merged into CII over 2 years ago. And I served as the inaugural chair of the CII Technology Committee for 2 years. And currently, I serve as the chair of the AWP Joint Working Group that has been discussed by my team members here already a little bit earlier. I'd like to say and emphasize what a special team this has been and what an honor it has been to serve with these colleagues, not only in the joint working group, but also in the subcommittee that has executed the work we're about to dive into detail of and describe. It has been really quite phenomenal, and I would love to have follow-up on, and we've already received some questions on how we executed this work, because I want to state that this was no small undertaking. It was a very tall ask that was made at the CBA in-person meeting last year in San Diego to, by the end of the year, have a draft of AWP data requirements by year end. I think there was a general call, mostly from those owner organizations, that said, why isn't this in place already? And for those of us that have been working in the digital space for a while, it is sometimes considered an onerous task to develop this type of work. And there were some issues that this team was able to overcome in a short period of time that was really quite phenomenal. But I'm actually going to dig in now to the nitty-gritty of the subcommittee work that actually developed the data requirements for AWP and also the implementation guideline that accompanies it. And I'm going to start at the beginning. ConstructX was present at last year's CBA meeting where Jay, if you heard this morning, and in conjunction with other owners, made a call for this work to be executed by year's end. We were actually doing a workshop on some IP that we donated last year to CII, and the call for this action came at the end of that meeting. And as we were sitting there and this call was made, I was personally was like, how are we going to execute this? And I want to get this done. I want to see this work accomplished. How do we execute? And I knew immediately that ConstructX was sitting on top of this IP, obviously because I work at ConstructX. But what you're looking at is has been developed by ConstructX mainly through the experience and knowledge of Ted Blackman, our founder and CEO, of what we call a digital thread framework. And over years, decades, had developed this library of digital threads, which, as described by Steve earlier, has a data requirement embedded in it. And it was very comprehensive. And we had already decided to donate this digital thread framework to the project team you're going to hear the results of later on today, right after this session. So we were already willing to donate this IP, and I thought if there was any way that we're going to execute this ask for data requirements, we have to have a starting point. And this digital thread framework was pretty comprehensive and would give this team the jump start it needed to execute this AWP data requirements documentation by the end of last year, at least in rough draft form. So we did. We talked about it. We donated this IP. One of the first decisions the team made, the subcommittee, the sub-team that was led by Tom Morris, made in relationship to executing the work was the adoption of this digital thread framework in order to kickstart the work of the subcommittee. And if you can go to the next slide, the first major activity was taking that digital thread framework, analyzing it, which took a little bit for the team, let's say, to wrap their heads around. And we had several sessions, both virtual and in person, where we talked about the digital thread framework, where ConstructX shared its knowledge and information about the framework. And then what that team did was take that knowledge and that information and determine what from that framework was directly applicable to immediate AWP data requirements, bare minimum AWP data requirements. And so they took the 30 some odd ConstructX digital threads and narrowed it down to 23 essential AWP data requirement categories that align to these 6 project execution phases. That this diagram came directly from RT272, seminal work on AWP for industry. And that was the first major activity that the subcommittee adopted. And embedded, of course, within the digital threads that they took were the actual data requirements that then I'm going to hand over to Adam, and he's going to talk about what the team did with that baseline data requirement. So over to you, Adam.
Thanks, Ted. Good afternoon, everyone. I'm Adam Messersmith. I work at Kiewit, and I contributed to this team with my international field experience through various disciplines from the EPC perspective. I've worked in lockout tagout, construction, project controls, commissioning, project turnover, EPC project reporting, and project information management. I'll show you our team's approach and methodology to this effort. The AWP Joint Working Team was formed to define and release an implementation guideline to AWP data requirements, as Ted just mentioned. We took a unique approach to this effort that was new to CII. We did not formalize a project or seek budget. Instead, we formed a volunteer core team and engaged academia, owners, EPC contractors, suppliers, and other SMEs as needed. Our goal was to have a flexible yet industry-aligned way of approaching and facilitating AWP. Beginning last fall, our team met face-to-face in several workshops and then in virtual meetings once the pandemic changed everything. Next slide. Yep. The AWP Joint Working Team mined each of those digital threads to identify the underlying data requirements from an industry perspective. We took the 30 some odd digital threads that ConstructX provided as a base layer and identified the 23 data requirement categories that were essential. We then subdivided each of these data requirements into subcategories based on the most logical grouping. For example, the data requirement for pipe detailing was broken down into the following 3 subcategories. Isometric detailing, used in tracking commitments and progress of ISOs. Isometric transmittals, used in tracking the relationship between each transmittal and ISO. Pipe spools, used in defining the full spool list and relating to ISOs. As the index of subcategories began to take shape, we were ready to progress to the next phase. Over several months, we rationalized each subcategory. During this, we identified the core fields needed by downstream users and the fields needed to build relationships to other data sets. We're not prescribing the structure of any database, but wanted to capture these interrelationships between the different data sets. For each subcategory, we define the primary keys to establish the appropriate level of detail, whether the field was considered required or optional, the field name, and its usage. In this spreadsheet format, we were able to unify common definitions and add fields across several tables as needed. It was an iterative process that continually refined each subcategory as we worked through them all. Once we reached a higher level of confidence on all data requirement subcategories, we transitioned into drafting the implementation guideline. Next. Yep. Through this process, we included an introduction to AWP, documented the project framework our team used to govern our approach, and set the structure each section would follow. Each subcategory would contain the following: a table listing description, sources, timing, and frequency of data collection, the purpose of the subcategory, a full attribute list where we defined every attribute and identified which would be the primary keys, discussion points to provide context where we included tips or the team's perspective on certain attributes, and also sample data. During this effort, we found ourselves further refining and rationalizing the data requirements. The implementation guideline we provided will be an evolving document, and the working team plans to update it as the industry provides feedback and AWP maturity grows.
Okay, so really appreciate everyone tuning in. I know this has been a lot of work for the team. I haven't gone through and summed it up, but my guess is this is easily a 4-figure work hour effort done primarily by volunteers. So I also want to express my gratitude to all my teammates. I likewise learned an absolute ton through this. And I'd like to introduce a call to industry. And I'll reiterate this at today's closeout, but we have an opportunity here as a construction industry. This set of data requirements gives us a beginning foundation by which we can make this digital enablement that we all keep talking about truly a reality on our projects. So my ask of you as the broader industry is, don't let this sit on a shelf and collect dust. Take it off the shelf, give it a look, and as we'll be sharing later, this team does not intend to ride off into the sunset. We plan to be agile, we plan to be responsive and dynamic. So as you're looking at this and you have feedback, you have experience, you have thoughts, we're looking for all that. This is the beginning of a journey and the beginning of changing what we can do as construction. So I appreciate your attention, and we look forward to fielding your questions. Thank you.